Exercise 3.1. Question number 1 is write the number of rows, column and order of the following matrices. Three things we have to find. First of all, we have to find rows. If we see part 1, the horizontal lines are called rows. So there is only one row. So we can write rows are equal to 1, and here are two columns from top to bottom, so number of columns equal to 2. Next thing we have to find is order of the matrix. So order of matrix is equal to rows by column. So here are one row and two columns. So order of this matrix is 1 by 2. Okay, now move to second part. Here are number of rows. If we see the number of rows are 2, so we can write here rows are equal to 2 and columns are also 2. So columns equal to 2. Now we have to find order of matrix, which is given by the formula R by C, mean rows by column. So here are two rows and two columns. So order of matrix will be 2 by 2. Now move to third part, which is 5 by 7. It is a single element. So it is a row matrix or column matrix. So here are rows is equal to 1 and columns are also equal to 1. So order of matrix will be R by C, which is equal to 1 by 1. Now last part of this question is, if we solve this, we have a single digit, mean it will become 2 times 1. First of all, multiplication will be solved. So 2 times 1 is equal to 2. 4 plus 2, 6. 6 plus 5 is equal to 11. So it is a row matrix or column matrix because it has a single row or single column. So rows are equal to 1 and columns are also equal to 1. Hence order of this matrix is R by C, which is equal to 1 by 1. Don't multiply 1 by 1 or 1 by 1 or 1 by 2 and make 2. It's wrong because 1 represents rows and 2 represents column. That's why we write it as it is. Now question number 2, check whether the following pair of matrices are equal or not. Two matrices are given, or we can say that one pair of matrices is given, and we have to find that either these two matrices are equal or not. This one is simple, so we can write it as it is 1 0 0 1, and this one is 25 minus 25 will be equal to 0, and 25 square root is 5. 5 by 5 it will be 1. 16 square root is 4. 4 by 4 is 1, and 16 minus 16, 0 0 square root will be 0. If we see these two matrices, its order is 2 by 2 and its order is 2 by 2. Order of both the matrices are same, but corresponding elements are not same. Here first element is 1 and here first element is 0. So that's why these matrices mean 1 0 0 1 is not equal to 0 1 1 0. Here you can put not equal to, or a step extra you can do to verify that these two matrices are not equal. Now move to second part. We have to prove that, or we have to show that these two matrices are equal or not. So this matrix is 1 2 3, and we put equal sign and add these because it is a single number. 3 plus 2 plus 1, it will be 6. So absolutely you have noted that these two matrices are of different order, so these are not equal. The third part is 1 by 2. It is a single element. We put equal sign and it is 1 2. So these are two elements and it is single. So you can verify that order of both matrices are not same, so these matrices are not equal. Next, move to fourth part, which is the last part of question number 2. If we add these two numbers, we will get 1 0 0 1, and let this is equal to 5 times 5 25, 25 divided by 25 it is 1. 3 times 0 0, 0 by 7 is 0. 15 plus 2 17, 17 minus 17 it will be 0. Now 17 is cancelled. With 17 we will get 1. So if we see, order of both matrices are 2 by 2 and corresponding elements are also same, 1 1 0 0 0 0 and 1 1. So these two matrices are equal. Question number 3 is Heather, Hassan and Ahmed scored 7 points, 11 points and 10 points respectively in a math quiz. Display data in row matrix R and column matrix C. First of all, we will make row matrix. So row matrix 7, 11 and 10. So 7, 11 and 10 are written in the form of one row. And next he also demanded us that write the given data in column matrix. So column matrix is represented by C and we have to make one column of this data, 7, 11, 10. So 7, 11 and 10 is written in column form. Question number 4 is write the most appropriate type of the following matrices. Dear students, 5 and 5 both are same number other than 1. If 1 1 mean 1 0 0 1, that is called unit or identity matrix. But if the numbers are other than 1, then it is called scalar matrix. Okay, why it is called scalar? Because at diagonal the numbers are same other than 1 and remaining elements are zeros. So this is a diagonal matrix because numbers are not same, so we can call it diagonal matrix, or you can also write it as number of rows are 2 and number of columns are also 2, so its order is 2 by 2, which is also called a square matrix. So move to third part, which is 15 times 3 will be 45 and 9 times 5 is 45. So 45 divided by 45 is 1, which is called unit or identity matrix. Unit matrix, or it is also called identity matrix or identity matrix. Now move to fourth part. Square root of 625 is 25. So 25 by 25 it will be equal to 1. And 17 plus 15 32 minus 32 it will be 0. 18 plus 1 19 minus 19 0. So square root of 9 is 3. 3 by 3 is 1. So it is also called unit or identity matrix. Okay, next final part of this question is 6 plus 2, it is 8 0 0 8. You have noted that 8 and 8 are same, so it is scalar matrix. Question number 5. Check for symmetric and skew symmetric matrix from the following. Dear student, first of all, you have to name this matrix. Let us, it is A, and A is 5, 2, 3, 2, 9, 6, 3, 6, 3. Now we have to take its transpose. A transpose will be equal to, transpose mean this is first row, so first row is converted into first column, 5 to 3. So 5 to 3 now in first column. Second row is 296. 296. We have made it as second column. Third row is 363. So we have to make it third column. 363, it is a row. So we convert it into third column. 363. 363. It is third column. Dear students, if you note that A transpose is same as A. So if A transpose is equal to A, if this condition satisfies, that if we take transpose of any matrix and transpose of that matrix is equal to itself, then we can say that this matrix is a symmetric matrix. So A is symmetric. Okay. Now move to second part, which is 0, 9, minus 9, 0. Let us suppose that it is A. A is equal to 0, 9, minus 9, 0. So we have to take its transpose, which will be first row is converted into first column, 0, 9. And second row is converted into second column. So it will be minus 9, 0. Okay. Well, there is a sign difference. So if we take minus as common, we will get 0. Minus is converted into plus, it will be plus 9. Plus is converted into minus 9, and 0 is neutral. So A transpose is equal to minus, this is the value of A, 0, 9, minus 9, 0. 0, 9, minus 9, 0. So it is minus A. There is a simple difference that A transpose is equal to A. A is symmetric, and if A transpose is equal to minus A, it is skew symmetric. So A is skew symmetric. Okay. Now third part is, let it is A. So we have to take its transpose. A transpose is equal to 0, minus 2, minus 4, 0, minus 2, minus 4. First row is converted into first column. Second row, 2, 0, minus 2. 2, 0, minus 2. It is now second column. And third row is 4, 2, 0. 4, 2, 0. It is now third column. So A transpose, now take minus as common. So if we take minus as common, it will be 0, minus 2, minus 4, 2, 0, minus 2, 4, 2, 0. Sign change. If we take minus as common, then sign of each number will be changed. So in this case, A transpose is equal to minus A. So it will be skew symmetric. Now move to fourth part. D, let us suppose that A is equal to 0, minus 7, 7, 0. So we have to take its transpose, which will be 0, minus 7, 7, 0. First row, first column, second row, second column. So A transpose is equal to, we have to take minus as common. So it will be 0, minus 7, 7, 0. This is the value of A. So A transpose is now equal to minus A. So it is skew symmetric. Now move to final part of this question. Let it is A. So we have to take its transpose. So A transpose will be equal to 0 minus 5. It will be first column, and minus 5 0, it will be second column. A transpose is now same as that of A. So there is no change after taking its transpose. A transpose is same as that of A. So it is symmetric. Okay. Question number 6 is write a symmetric and skew symmetric matrix of order 3. Dear students, one example of symmetric and one example of skew symmetric is there of order 3. 3 rows and 3 columns. This is also 3 rows and 3 columns. So if we take its transpose, it will be 5 2 3, 5 2 3, 2 9 6, 2 9 6, 3 6 3, 3 6 3. So after taking transpose of A, it is equal to same as it is A. So A transpose is equal to A. This is the condition for symmetric matrix. Okay, now move toward skew symmetric of order 3. We have to take its transpose, so it will be 0 minus 2 minus 4, 2 0 minus 2, and 4 2 0. So we have to take minus as common. A transpose will be equal to, after taking minus common, we will get 0 minus 2 minus 4, 2 0 minus 2, and 4 2 0. After taking minus as common, it will become A. So now A transpose is equal to minus A. So we can say that A is skew symmetric. Thank you for watching my channel. Also subscribe it.